we're not going to be just looking like, if we start off with a sentence. So if we start off with a sentence, quick brown fox jumped, okay? And let's say you have a document that has like 100 rows like this of different one-line sentences, okay? What you're going to do is you're going to map each row, 1, 2, 3, etc., into something, all right? And you might map this in and refer to it as X, and you might map that in as Y, and that is Z, and I don't know, we'll call that Q, okay? And then you'll refer, and then you could say something like, you know, do word search on X, meaning I want to know a word count, but I only want word count for the first letter. So you do a subset of data from all the rows and just give me the X field, and then count out the X field or something like that. My point is, you will take input strings, you will map them to names, so you can refer to, you're not referring to quick, you're referring to the first word in the many rows of data you have. If it was only this, it would be relatively simple. But the other thing you will do is, you may, for instance, take these two together and say, no, I want to treat the first two and call that X, and X is a tuple. And a tuple doesn't mean two. A tuple means a set. You could even say, I want quick brown fox to be a tuple. Okay? So the point of all this is you will take individual pieces of data and put them into groups, logical sets, and you'll call those tuples. And then there's a special kind of tuple called a bag. And then there's a map, which is a relationship. So let's move on. I don't expect you to understand that, but I've got a few slides here to hopefully get us through this. So they call these the complex types because the other things, like if you map it to a string or an integer or a floating point, that's considered a simple type. But the complex types are, in effect, it's special data types that you're kind of defining yourself. So a tuple is an ordered set of fields. And then a bag is a collection of tuples. If you create a couple tuples and you want to put them all together in one thing that you want to refer to as like the person's address, and you know, one tuple is their street number, and another tuple is their street address, and another one is it a street or an avenue, and you put them all together into a bag, you have a collection of tuples. And then a map is a set of key value pairs, and we will use maps to express operations we want to do on the data. We'll say, take this data, use this map, and transform it. So you can think of a tuple as a row with one or more fields. So a tuple could just be 19, or it could be 19, 2, or 19, 2, 6, and the data types don't have to be the same. It could be like this one, 18, 1, Joe. That's still one tuple inside of that bag. Here's another example where I have a floating point in there. So then a bag can have duplicate tuples. They don't have to all be unique. And the tuples in a bag, like that second one has 2 and one has 3. They don't have to be consistent, completely flexible. Now, if, for instance, you had a bag and it had 16 tuples in it, and 15 of them had 3 fields and one of them had 2 fields, then when you wrote one of your operations, the system's going to say, well, that one's missing a field, and it'll just plug a null in there. So the system's sort of biased towards, if most of the data has 4 fields and it comes across one that only has 1 field or 3 fields, it doesn't stop. It just puts nulls in there. And a lot of times that's okay, because you'll create, you'll calculate totals and it'll be fine that it's null. And then it's saying the tuples can have fields with different data types, but if it's really going to be effective and you're going to get logical sense out of them, the tuples in the bags should be the same. So it's okay that, like, in this one, it's John, you know, so it's called, this is called a string array. They don't call them string, they call them a string array, or a character array, I forget. String array, integer, floating point. It's okay, if you have 10 more of them, and they all are of the form string, integer, floating point, that's good. Then the data's going to be processed correctly. If this one was, if one of them was string, string, floating point, it's going to be left out of the calculation. It won't fail, it just will reject it because it doesn't fit the model.
I don't quite understand. So tuple can have different data types? Is that
Yes, yes.
And a bag is like
A bag is a collection of tuples.
so it wouldn't depend on what data types.
No,
Okay.
no. The tuples in the bags, unlike like C#, they don't have a type. They can be anything.
So you mentioned that if there is 2 string array and 1 floating, it wouldn't understand, does it? Or
If you fed some data into it, and you had like 10 tuples, and 9 of them were of the form string, integer, float, and 1 of them was string, string, float, and you told it to like do an operation on those 10 tuples, it would just ignore the one that didn't match. It wouldn't stop, it wouldn't fail, it would just give you 9 values. One of them would be lost.
so all the 10 should be the same.
If you want consistent data, okay? So I don't really understand this, so you have to take everything I say with a grain of sand, but imagine you were getting receipt data from a Target cash register, okay? And one of the receipt values, for whatever reason, there was a glitch in the network, it was missing the price field, okay? So then you run a job at the end of the day to calculate how much we sold. You'd be going chunk on each row of data, and you'd come to this one tuple, and that value is not there. You would throw that record on the floor and ignore it, and just keep processing. So you would have lost one transaction, but on big data, you never care about losing one piece of data, because it's always thousands.
You can still essentially search the tuples themselves after you've got a bag.
You can still do all of them?
Search the tuples separately.
Oh, yeah, you can process.
The field from the tuples.
Oh, yeah, you'll be able to do everything.
Great, because I've got a large set of data that needs the multiple fields, needs the nulls, but also needs to be able to essentially search on the fields inside the tuples to actually use it.
So here, I tried to use colors to make things consistent. So there are 2 kinds of bags. There's is technically, I think it's called an outer bag, but most people call them a relation, and I have no idea why. And then there's something called an inner bag. So this is sort of like real data. So we have an outer bag, and its name is my data. Okay, my data is an outer bag. You see, I say my data equal load data. That is a load operation. And that's saying, let's assume it's going to read 100 lines of data, and each row of data has 3 integers, and the next line has 3 integers, okay? So it's going to load up this bag thing, this outer bag, with 100 of these tuples, and the tuples will all be a series of 3 integers. That's an outer bag, okay? And it's a bag of tuples. And these tuples in this example, I'm pretending that we only read that much data. We only read 4 rows of data, and the data looked like that. And this is when I did a dump. Dump is a short and quick way of saying to Pig, what do you look like now? And dump will just spit it out on the screen for you. So I don't show the input stream for this, but it would look almost exactly like this without the parentheses. It would be 1, 2, 3, carriage return, 4, 2, 1, carriage return. And you would say, my data equal load data and as, and then you would say, how do I want to treat 1? Treat it as an integer. How do I want to treat 2? Treat it as an integer. I could say int string, at which point this 1, 2 would be integer, integer, string 3, if you wanted to. And again, wait till I get through about 4 or 5 more slides, because I literally just go through this over and over again with different examples to try to get you to get it. Now, an inner bag has a field and then a bunch of tuples inside it, whereas that one only has, I actually don't show that, I don't show that one the way I show this one, but here it is dumped. So an inner bag, this is a verb. I'm grouping this relation up there, my data. I'm grouping that data by the first field to form a relation X, which is a relation or bag of tuples. So, some of these lines are real lines of code. We could actually run this. I say my data equal load. And if I had the right data, and did a dump, I would get that data out. Now, if we were in interactive mode, I could then just go ahead and say X equal group A by F1, okay? Now, what is F1? We defined F1. F1 is the first field. So we're saying group it by the first field. So it takes the first field 1 and puts it there, takes the 4 and puts it there, takes the 8 and puts it there. And then it says group by, well, all the ones that start with a 1 are here. All the ones that start with a 4 are here, and all the ones that start with an 8 are there. Now this is a very simple example, but you can imagine if you were trying to calculate, you wanted to list all the words in a book that started with A or B or C or D. Then, you know, you would take the first letter, and this would be strings instead of integers. This would say A, and this would be all the words that start with, this would be a better example, all the strings that had words started with A.
So would it give out words instead of, like, if we say starting with A, it would print out apple, aeroplane, and that way, or will it just give us the count?
I don't want to answer that question because there's too many variables. I want to wait until I have an example so I can point to it. It's a perfectly good question. It's just too hard to answer in this language. So in this example, these things are called inner bag. And the inner bag is part of this relation. So we've defined this relation, and it has two fields. The first field is type int, and the second field is a bag. We defined it that we wanted the second field to be a bag. And we're saying X, group A. Now this A, wait a minute. Where's this A? Group A.
Data.
You know, this is really not right.
So group my data.
That really should say,
Yeah.
this really should say
My
group
data.
my data. And I'll get a little bit ahead of myself, but this is the way this language works, is you process the data in one step, and the output of that first row is called my data. And then you have another line where you take that line in as input, process it, and now you create a second subset of data. The next line can say Z is equal to X transform some way, or the next line could say Z is equal to my data transform, because each of these lines and the data sets they represent, they're still there. It's not like a regular language where you calculate it and then you move on. I've defined my data as that collection of data, and I can use that word my data over and over and over again, and it represents that subset of data in that format. And I can use X over and over again once I've defined it.
Does that mean that you can say group it by F1, comma F3, and so it would prioritize groupings by the first field
It
and then the third field, second one.
F3 would give you the same results because, well, actually no, it would give you the.
I could do another one. I could say Z is equal group my data by F3. And then this first number would be a 3, and
You have
these
two
two would go
sets.
together, and this number would be a 1, and that number would be a 4.
An 8.
Hold on, let's look at
One of them would be an 8. Oh wait, no, you're right, 4.
What is it? I guess like the second one is defined as, or the first field
I
is
get it.
defined as being. Where is the second field? I have to define as being. Is it just when you start? When you just do other than that
She's asking, this is defined as an int. Where is that defined as a bag? That's defined as a bag because you're pulling in my data, and my data is a collection of bags.
It's the group.
Okay, a map, this is not so related to the other slides yet, it'll come back in. A map is a set of key value pairs. So name, pound John, phone, pound that. So those are key value pairs, and you'll see how we use those later to do these transformations. So there are things called expressions. And you use expressions to filter, to for loop, to group, to split, and there's even something called eval. So an arithmetic expression could look like this. X is, when you say X equals, or my data equals, or Z equals, you're defining like a new subset of data, a new big chunk of data. So this new set of data X is, you get it by taking A and grouping them by the result of multiplying F2 times F3. So that would go through every row of data in A, multiply F2 by 3, and then make a whole bunch of tuples.
We can't hear the teacher talking.
And that would make a whole bunch of tuples of the results of that. And then here's an expression where you would say, this new X is, you take the data that was in A, and for each row of data in the A, concatenate A and B. Now, A and B would have to make sense in the context of A. We don't know what A is. But that's an example where you could go through and combine all the, like if the initial expression had pairs of words, you could just force it all into concatenated. And then here's a Boolean expression. Go through and filter A, which means X will have a subset of A, and do it where either something you've called F1 is equal to 8, or when F2 plus F3 is less than F1 not.
Greater.
So that would just be a way of getting a subset of the data. And again, you have to like think of these expressions as possible ways of doing what you're trying to do. And then a star can be used to represent all fields of a tuple.
So it returns the backs.
Say that again?
So the axis will be the backs.
The X will be the what?
Backs.
The mask?
Backs.
Bags.
Backs.
It'll return
Bags
bags.
is too bigs.
Backs.
Oh, bags.
Yeah.
Oh. Why are we talking about bags? This is a computer programming course. X will be a whole bunch of bags. Each row of data that was in A will result in X having, if there were 100 bags in A, there'll be 100, well, assuming the filter doesn't get rid of some of them, there'll be 100 bags here, but they'll be changed. In fact, let's say there's 100 bags in A. If any bag that had F1 equal to 8 will be in X, and any bag where, remember that original we had 3 integers? If you add these numbers, it's less than F1, and then you invert the sense, it will be in here. So let's pretend this had 100 elements in A. X might have 52 bags in it. Okay, so let's try to walk through this one. So this X, this A, X, and Y, these are like transformations of the data. And like I said, they still exist. A's still here, I can still use A.